In this module, we'll be talking about web trends. Web technology is changing at a rapid pace, making it challenging to predict what tools and behaviors will look like even a few years from now. This rapid evolution is a major consideration for web developers who need to stay current with the latest trends and technologies. As the famous baseball player and manager Yogi Berra once joked, it's tough to make predictions, especially about the future. This quote perfectly captures the uncertainty of predicting technological trends. Now let's talk about web browser market. More than a decade ago, there was intense competition among browsers like Internet Explorers, Firefox, and Chrome, each vying for market share. However, in recent years, the browser market has stabilized with fewer significant changes. Most users today rely on a few well-established browsers such as Chrome, Firefox, Safari, and Edge. And these browsers tend to have a consistent market share. For the web developers, the stability means that the primary focus should be on creating web applications that adhere to current technological standards. It's important to ensure that web page work well across all established browsers rather than depending on features that are specific to one particular browser. This approach helps avoid frustrating users and ensures the consistent experience no matter which browser they use. So this is just a statistical graph where it shows over the years which browser is more prominent. Now we can see Chrome has been more popular recent years. Internet Explorer has declined quite a bit, but still it's popular. And there are some other browsers that's being used as well. Um, Today, we are seeing a significant shift in how people access the web. Mobile web devices like smartphone and tablets have overtaken desktop computers as the primary means of accessing the internet. I'm pretty sure some of you are watching these videos and completing this course on an iPad or a tablet like device. And in few cases, there might be some students who are using their phones to view these contents. So this shift has important implications for web developers. To give you a sense of a trend, let's look at some statistics. Back in 2012, desktop usage dominated with about 90% of the web access coming from desktop computers. However, by 2024, the number has dropped to around 40%. Meanwhile, mobile usage has seen a drastic rise. Starting from almost 0% in 2009, mobile usage has grown to account for 60% of web access by 2024. These figures come from StatCounter Global Stats, reflecting data from 2009 to 2014. So this is the graph I'm talking about. So desktop from 100%, almost 100%. So it was 90%. It came down to around this number. And then mobile devices has surpassed our desktop internet access users. So given the significant shift towards mobile, developers need to prioritize mobile-friendly design. There are several critical considerations to keep in mind when developing for mobile service devices. Number one is the screen size. Mobile devices have much smaller screens compared to desktops. This means developers need to design layouts that are easy to navigate and view on smaller screens. Then load speed. Mobile internet connections can be slower or less stable than desktop connections. It's important to optimize websites for faster loading times to accommodate users with limited or slower internet connectivity. Then device performance. Mobile devices typically have less memory and slower processors than desktops. Therefore, web pages should be optimized to run smoothly on these less powerful devices. And then data cost. Many users have data plans that limit how much they can download. Websites with large files that consistently request more data can quickly consume a user's data allowance. Developers should be mindful of data usage to avoid driving up the cost for users. And then battery life. Mobile devices rely on battery power, so websites that frequently run complex JavaScript or constantly load data can drain a device's battery quickly. Developers should aim to create efficient web pages that minimize battery usage. Finally, user interface. Interaction relies on touch rather than a mouse. So unlike desktops where users interact with the mouse, mobile devices rely on touch for the user interaction. Developers need to design touch-friendly interfaces that are easy to use on smaller screens. So Now let's talk about IoT or the Internet of Things. This is one of my favorite topics. I do active research in this area. If any of you are interested in doing collaborative research or do a research credit with me, feel free to reach out to me. I will be happy to accommodate or collaborate with you. So let's move on. What is IoT or Internet of Things? IoT represents the global network of devices that are capable of sensing, communicating, and controlling various aspects of our environment on behalf of humans. These devices can range from simple tools like temperature sensors to highly advanced equipment such as satellite-based laser scanners that can discover archaeological sites hidden under dense vegetation. To give you an idea of the diversity of IoT devices, let's consider a few examples. One example is the Nest thermostat, a smart device that monitors and controls the temperature in homes. Another example is an internet refrigerator, which not only keeps food fresh, but can also display useful information like weather reports on a screen embedded on its front panel. IoT devices typically display one or more of these following characteristics: sensing the physical world. These devices gather information from the physical environment using various sensors. Examples include measuring temperature, monitoring voltage, or capturing images. Data sharing: IoT devices share the data they collect with control systems. For instance, a temperature sensor might send information about a room's temperature to a building's control system, or sensors that detect air quality might report data to urban environment monitoring systems. Third is the executing commands. IoT devices can interact with other hardware to execute commands sent by control systems. For example, if a sensor detects that a certain area of a building is cooler than desired, the system might command a fan to speed up and distribute hot air to that area. People do not usually interact directly with IoT devices. Instead, interaction typically occurs through custom applications or web pages that provide a user-friendly interface. This is where the web developers play a crucial role. They build the web pages that provide an overview of the system and allow users to access specific information from the aggregated sensors data. These web pages can also enable users to adjust system parameters or activate and deactivate certain parts of the system remotely. Now, let's talk about web accessibility. Today, we're going to talk about web accessibility, in which all about ensuring that everyone, including people with disabilities, can access and use the web with reasonable effort. Web accessibility is crucial because it ensures equal access and opportunity for all users, promoting inclusivity and preventing discrimination. So, web accessibility involves designing web pages that can be easily accessed and navigated by users with disabilities. To develop accessible web pages, it's important to have an understanding on the various disabilities that can affect web use. The assistive technology and software that help users with disabilities and base design practices to make content compatible with these tools. Some common disabilities that impact web accessibility include visual problems. These range from complete blindness to low vision and color blindness. Users with these issues often rely on screen readers and other assistive devices to navigate websites. Second is hand control issues. Conditions such as tremors or total inability to use hands can make using traditional input device like a mouse or a keyboard difficult. These users may use alternative input devices. Seizures, certain types of content, especially those with flashing lights, can trigger seizures in some users. Developers need to be cautious about including such element in their designs. Cognitive challenges, conditions like dyslexia and other cognitive impairments can make it difficult for users to process complex web pages. Simplifying navigation and providing clear, straightforward content can help in this scenario. People with disabilities often use assistive technologies like screen readers, voice recognition software, and other alternative input devices. As web developers, it's our job to ensure that our websites are compatible with these technologies, allowing everyone to access and interact with web content. To understand the importance of web accessibility, let's look at some key milestones in its evolution. In 1973, the Rehabilitation Act was passed, prohibiting discrimination based on disability for federal agencies and programs receiving federal assistance. The American with Disability Act ADA of 1990 further emphasized that communication with people with disabilities must be as effective as communication with others. By 1998, the Rehabilitation Act Section 508 requires that all federal websites and technologies be accessible to people with disabilities, ensuring that federal employees and public could access the information. The Web Content Accessibility Guidelines, WCAG 1.0, introduced in 1999 by the W3C, provided the first set of international standards for making web content accessible. In 2008, WCAG 2 was released, offering updated guidelines with new success criteria to improve accessibility. Further updates came in 2018 with WCAG 2.1, which addressed issues related to mobile devices, low vision, and cognitive disabilities. Most recently, in 2022, the Department of Justice released guidance on how government agencies and public facing businesses can ensure their websites are accessible as required by the ADA. Cognitive computing refers to use of artificial intelligence techniques combined with access to vast amount of data. The goal is to simulate human problem-solving abilities, especially in situations that involve ambiguity, changing data, or even conflicting information. Cognitive computing systems are designed to handle real-world complexities that traditional computing might struggle with. These systems aim to mimic human thought processes, enabling them to understand, reason, and learn from large data sets. They can process information in a way that closely resembles human cognition, making them highly effective in areas where nuanced understanding is crucial. A leading example of cognitive computing is IBM Watson. Watson has become a symbol of this trend, representing the potential to create intelligent software systems capable of processing massive number of web pages and the data sources. Watson is used to tackle challenging problems across various fields. In medical treatment, Watson can analyze vast amounts of medical data to help doctors make more informed decisions, leading to the better diagnosis and treatment options. In retail, Watson can understand consumer behavior by analyzing sales data, helping business increase their sales and improve customer experiences. In customer support, Watson can enhance the quality of call center help by understanding and responding to customer queries more effectively, improving overall customer satisfaction. The key factor that enables systems like Watson to function effectively is the use of web page metadata and structure markup. When processing information, these systems rely on structured data to make sense of the vast amounts of information they encounter. Metadata provides context, helping the system understand what the data represents and how it can be used. For example, imagine a web page with text that includes numbers. If the numbers are placed in a structured format, such as an HTML table with a clear title like pacemaker failure rates, the system can easily identify the extract relevant information. This structured information approach makes the data more useful and easier to intelligent systems to interpret. So thank you. See you in the next slide.